In finding the general solution or the particular solution of a differential equations, there are many ways or different methods you could use to solve your differential equation. And one of the methods we are discussing today is the separation of variables. So we are looking at separation of variables today. We know that the simplest form or the simplest type of differential equation. So let me say the simplest form or the simplest type of differential equation is y prime to be equal to what? F of x. So let me say the simplest form of differential words equation. Okay, so with this form of differential equation, you could actually solve this differential equation by integrating. So we could solve by integrating to get a solution, so that our solution y will be equal to the integral of what? F of x the what? X. So with that simplest differential equation, the solution could be solved as this. But if you consider a first order differential equation, we can say it is separable. And if it's separable, you can write it in that form. So we've been able to write our differential equation, let's say dy dx, should be equal to, let's say, f of x, y. I could equally write it as, let's say, f of x. I want to write, let's say, g of y. Okay, so this is what's a first order separable differential equation, or equivalently, or you could also write it as, let's say, m function of x and y dx plus, let's say, n x and y dy to be equal to what? 0. So this is what the form of what differential equation that I could what write. So that if I have this type of differential equation, let's say from here, then what happens is that if I want to solve for this differential equation where my f and g are continuous, then it is going to have this solution. So you realize that it's going to have this solution such that my integrals, I have the integral 1 over g of y dy to be equal to the integral f of x plus f of x, let's say dx, because it's integral, plus what? A constant. So technically, what we are trying to do from here is we group all the variables. If it is x, you group all the x with the x to one side and all of y with the y to another side. So let's look at an example here. So let's take this example. If I take the differential equation, so I have this differential equation, x plus 1 dy over dx to be equal to x y squared plus 1. This is what my differential equation. So this is a differential equation. So let's say this is what dE. It's what the differential equation. What do we want to do? We would want to write it in this form. So I can write it in the form of m x y dx plus n x y dy to be equal to 0. What do I want to achieve by that? What I want to do is separate what the variables so that all y goes with y and all x goes with x. So you realize that from here, if I try separating the variables, what do I have from here? So let's cross multiply here. You realize that I have x plus 1 dy dy. So I have x plus 1 dy to be equal to, I have x y squared plus 1 the words x. Okay, this is the x. We want to group it with the x. This is with y. So I want to take it to the y. So what do you realize? You realize that with this, I can divide through by x plus what? 1. So even if I divide through by x plus 1, x plus 1 here, what do I have? This cancels that. So you realize that from here I have dy to be equal to x over x plus 1. Then I have what? Y squared plus 1 the words x. So we are still separating our variables, but we have the x with x here, but you still have y squared plus 1. So we want to bring it over to the y alongside the y. So what can we do? You realize that I can divide through by this, so that I have dy over y squared plus 1. Then I have x over x plus 1. Then I have y squared plus 1 over y squared plus 1 dx. So what happens? You realize that this cancels what? That. So finally, in separating the variables, what do we have? We realize that we arrive at x. So I have x. So from here I have x over x plus 1 dx to be equal to the y part, which is what? Y part here is what? This is that. So I have 1 over y squared plus 1 the words dy. Very good. So this is what we have been able to what? Separate the variables. And now that we have been able to separate the variables, we can find the solution by taking the integral on both sides. So let's integrate both sides. If you do that, let's write integral. So if I integrate, so I have the integral of what? X over x plus 1 dx to be equal to 1 over the integral of y squared plus 1 dy. Okay, so this is where we do a revision on our integration. So I urge you to revise your integration so well, because in finding solutions of differential equations, we'll make use of our integration a lot. So if you integrate this side, you realize that I can equally write this as what? The integral of x over x plus 1 dx minus 1. This is y over what? Y squared. So I have 1 over y squared plus 1 dy to be equal to 0. Take the integral on both sides, and this is going to give us, this part is going to give us x minus ln of what? X plus 1 minus, if I integrate this, what do I get? Arctan y to be equal to what? A constant. So anytime you do your integration, don't forget we always had what? A constant. So then this is what? The solution we have for what? Our differential equation. And this becomes what? The general solution. So you take your time and you go through as well. In our next lesson, we'll take more examples on solving a differential equation using the separation of variables. Kindly don't forget to subscribe if you are new to my channel. Like and share among your network as well. Thank you.